So getting to word problems, some strategies for these word problems is to highlight and underline important information or write out the given information, reword the question in a way that you understand it, even draw a picture. What I expect from all word problems is for you to write a let statement. An example of this would be saying let X equal whatever it is you're trying to look for. Create an algebraic expression. Show all your work, check your answer, and write a therefore statement. A common problem is a consecutive number problem. Consecutive means in a row, so numbers that come one right after the other. An example would be to try to find 3 consecutive integers that add up to 123. First, let's do a let statement. A let statement lets you know what your variables are. So let's use n. Let n represent the first number. So if n is the first number, the second number is 1 more than n. So n plus 1. The third number will be that first n plus 2. That makes them consecutive. You have a number, 1 more than the number, and then 2 more than that number. So now that we know what our variables are, we know that they can add up to 123. So the first number plus the second number plus the third number equals 123. First, second, third number. Now we have a type 3 equation, so we just need to group the variables together. I see 3 n's plus a 1 and a 2 makes 3. I'm going to move that 3 to the other side, so now I have 3n equals 123, take away 3. 3n equals 120. I'm going to divide both sides by 3, and my n, cancel, cancel. 120 divided by 3 is 40. So my first number is 40. So if my first number is 40, n plus 1 must equal 41, n plus 2 must equal 42. I'm going to check this to see if it works. Forty plus 41 is 81. 80 plus 40 is 120, plus 1 and 2 is 123. So it's been checked. So therefore statement, therefore and you're done. And if we were to look around, we can see there's a therefore statement. I've checked my work. I've shown what all the numbers are equal to. And if we move it back up, I've got my let statements, what my variables mean, my equation. I've solved it properly with my equal signs lined up, and the problem is done. Another common problem you'll come across is finding the perimeter of things. So this question here, what is the perimeter of this shape? It says 18. So what are the dimensions? We only have the dimensions with variables. So we know how to find perimeter. It's adding all the sides. We don't need a let statement. But you could make one. You could say, let x, it's already given, but let's say what it is, represent the width in this case. And our algebraic expression, you can write it two ways. I'm going to do a simple way, just by adding all the sides. So you have x plus x, so the two widths, plus x plus 5 plus x plus 5. So you have the width, width, length, length. It all equals 18. Now I'm going to combine like terms. I see 1, 2, 3, 4 x's and 2 5s. So 4x plus 10 equals 18. 4x equals 18, take away 10. 4x equals 8. Divide both sides by 4, and x equals 2. Width equals x, which is 2. Length equals x plus 5. Which is 2 plus 5, which is 7. Okay, let's do a check just to make sure that our answer works out. So check. I should be able to find the perimeter and have it equal 18. If I think the width is 2, I'll do 2 plus 2 for the two widths, and the length is 7 plus 7. That's 4 plus 14 is 18. So it checks out. I was looking for a perimeter of 18. Therefore, the dimensions are 2 and 7. And you're done. If we were to look around, we have our let statements, we have our equation solved properly, equal signs lined up, a legend telling us what things are, and then solving for length and width, 2 and 7. We have a check just to make sure we're correct, and then our therefore statement, and you're done. Okay, so a coin problem is one that we're going to come across. Suppose Bilal has 10 coins and quarters and dimes and has a total of $1.45. How many coins does he have? So the first thing we need to do is write some let statements. So let Q represent the number of quarters, and let D represent the number of dimes. So how many dimes you have? 2 dimes, 5 dimes, 6 dimes. So he has 10 coins. So that means Q plus D equals 10. The number of dimes altogether, number of quarters plus number of dimes is 10. They have a total of $1.45. So that's talking dollar amount at this point. Quarters have a value of 25 cents. So 25 times the number of quarters gives you your quarter value. Dimes are 10 cents. So the number of dimes times the value gives you that. So 25 cents times the number of quarters plus 10 cents times the number of dimes gives you $1.45. So these are our two equations that we're going to be using to solve. If you look at this one, there are 2 variables. I can't solve this with 2 variables. I need to replace one of these with something to get rid of it. So I'm going to look over here. I have another way of relating these 2 variables. I am going to say that dimes are equal to 10 take away the number of quarters. I've just rearranged this equation. Now I'm going to take this and put it over here. So 0.25 quarters plus 0.10 times the dimes, which I'm replacing with 10 take away Q. Now I have only Q, only the variable Q for quarters to solve this. First thing I'm going to do is the brackets. So 0.25Q plus 0.10 times 10 gives me 1. 0.1 times a negative Q gives me so ideally my equal signs should be lined up. Now I'm going to group like terms. I see this, and I'm going to group them together. So 0.25Q take away 0.10Q gives me 1, I'm just going to bring down, plus 0.15Q. The 0.15 is 0.25, take away 0.1. I would like the 1 gone. I want it on the other side. So I'm going to take away 1 from both sides. 0.15Q equals $1.45, take away 1. 0.15Q equals 0.45. Divide both sides by 0.15. And Q equals 3. So now, if Q equals 3, that means I have 3 quarters. I am going to use this and bring it back to this equation over here. The number of dimes, I'm just going to bring this down, is 10 take away Q. I know the value of Q now. 10 take away 3. Equals 7. So I'm going to do a check because I have some values for the number of dimes and the number of quarters. So if I did 7 times 0.10, 7 dimes, plus 3 times the value of a quarter, equals 7 times 0.1 equals 70 cents, plus 75 cents. 70 plus 75, so it's $1.40 plus 5 cents, $1.45. So it's verified. We are correct. Last step. Therefore, there are 7 dimes and 3 quarters. And you're done. Okay, age problems is another one, and the same thing, we're going to create 2 equations and use them to help solve this. Your mom is 3 times the age of your little sister, Molly. In 12 years, Molly will be half the age of your mom. How old is Molly and your mom now? Okay, so let's look at some relationships we have here. Let's look at right now. Right now, mom is 3 times the age of our little sister. So how about let's not use m because that could get confusing. Let x represent the age of Molly. Let y represent the mom's age. So your mom is 3 times the age of your little sister. Okay. So that means that 3 times the age of the little sister is the age of the mom. And if you wanted to write it in words, you could do that. 3 times age of Molly equals the mom's age. Okay? And we're going to use this to help us solve. So that's one relationship we have. In 12 years, Molly will be half the age of your mom. Okay. So if it's in 12 years, Molly will be X plus 12, her age plus 12 years, and mom will be Y plus 12. Except Molly will be half the age of mom, which means twice the age of Molly will equal Y plus 12. So here's twice Molly's age in 12 years equals the mom's age in 12 years. This has two variables, which I can't solve, but I do know this relationship. What I am going to do is substitute into this. It doesn't really matter which one you pick. I think I am going to pick x's. Actually, I want to keep it without division, so I'm going to substitute in for the y. So y is 3x's. So I have 2x plus 12 equals 3x plus 12. So now I have one variable and I can solve. First I'm going to distribute 2x plus 24 equals 3x plus 12. I notice that I have more x's on this side, so I'm going to group my x's on this side to keep them positive. So on this side I have 24 and my 12 comes over. And this 2x comes over and is negative. 24 take away 12 is 12. 3x take away 2x is x, and that's where we are. So if x is 12, I'm going to go back to this expression up here. Mom's age and Molly's age is the x. So I know that x is 12, so let's figure out the mom's age. So I'm just going to bring this down here. Three x equals y. 3 times 12 equals y. 36 is y. So let's see if that makes sense. Molly is 12. Mom is 36. So 3 times the age of your little sister. So 3 times 12 is 36, so that works. In 12 years, so if Molly is 12 and adds 12, it's 24. If 36 plus 12 becomes 48. And if Molly was 12 plus 12 becomes 24. And that is twice, so that works.